So what can you see about the horizontal distance between these dots? I mean the distance from this point to this point, this distance, and then the distance from horizontal distance only, from this point to the next one. What do you see?
It's all the same.
Yes. So what does it mean? Horizontal component of its velocity. It is always a constant. The motion of the object in this projectile motion, the horizontal component is always 4 meters per second. It is 4 meters per second here, Vx, horizontal component, okay? It is also 4 meters per second here, and even right before hitting the ground, Vx, because in the horizontal direction, the net force in that direction is 0. There is no reason to change the velocity of the in the horizontal component. Okay, so this horizontal velocity is always 4 meters per second. Okay.
Yeah.
Let me show you that on a real experiment. Let me find it on a video and change the share screen. This one. So each point here is a time lapse, a position of this ball being launched from this point on the table at different time interval, and of course the time interval are the same for each consecutive successive points. Okay. So what can you see about the horizontal distance between these dots? I mean the distance from this point to this point, this distance, and then the distance from horizontal distance only, from this point to the next one. What do you see?
It's all the same.
Yes. So what does it mean?
The horizontal
velocity is constant because the air resistance is negligible. Air drag is very small, negligible. Okay. But the vertical distances is not the same. You can see it here. This is the vertical distance between the two consecutive points, and now the next distance, you can see that it is increasing. Okay, meaning that the vertical velocity Vy is increasing. Okay,
so
and Vy.
Is it always like this in projectile motion?
Only when the air resistance is negligible, meaning that the size of the object must be small enough, and the speed is low. Because the air resistance depends on the speed. The faster the speed, the greater the air resistance, and therefore object that move with high speed and the size is big does not follow the projectile motion, and it is much more complicated, which you don't study. Okay.
Yeah.
So that's the point. Horizontal velocity is always constant, 4 meters per second. Show that the vertical component is 6.2 meters per second. Use the formula of the vertical component Vy equal Uy plus At, where A is the acceleration, which is 9.8 meters per second square. Okay, please write down that formula on the file. Vy equal Uy, initial velocity, plus Gt. It is increasing in the speed. The Uy here is 0. And then G is 9.8. And the time, we need to calculate the time. To calculate the time, we use another formula for the height. The height of the object fall is 1.96 meter. Okay, that height is denoted by the letter S, equal to ut plus 1/2 at squared. This formula called the Suvat, the big four equation that I taught you like 2 months ago,
Yeah.
Okay, so from this formula, u is still 0, and you can determine the acceleration as the time. Vertical component velocity. There's another method which is faster. Use the third one. Let me erase this one. We don't need to calculate the time when we use the third equation here. V square equal u square plus 2as. Okay, this is in the vertical direction only, meaning this is the initial velocity in the vertical direction, and this is the vertical component velocity. S here is 1.96 meter. Acceleration is 9.8 to that. This one is 0. Okay.
Mm.
And the final velocity here is what we need to find. So after calculating this value, we take the square root to get the answer, which is this one. Okay. Okay. So I'll erase this one, and I'd like you to write it again. You need to memorize a lot of equations because you're not provided a formula sheet. There are very little, only a few equations in the formula sheet. Using the third equation like this, we don't need the time. 6.2, beautiful. Do not need to take that many significant figures, huh? Just 6.2. Question B, the components of velocity are both vectors. Complete the figure, draw a vector diagram to scale, determine the velocity of the ball as it hits the horizontal plate. So the horizontal vector here is 4 meters per second, given in the previous part A, part A of the question. The other component that you need to draw is 6.2 to a scale, to draw it in the correct scale. So on the iPad, how do you do it? Use a ruler, put a ruler on this one, measure how long it is on the iPad, calculate the scale, so that you can draw a 6.2 meter per second vector. Okay. On a real paper, of course, you can use a ruler to measure the length, like 4 centimeters for 4 meters per second, and then 6.2 centimeter for the velocity in the vertical direction, 6.2 meters per second. So for now, we don't need to do it so too accurately. Just represent it like 6.2 here. 6.2 meters per second. Okay.
Doesn't it have to be on the right? Because nose to tail.
No, it should be here.
Why?
So that the total velocity, the actual velocity, is the diagonal of this rectangle. Okay.
But why can't it be here?
Because the actual velocity is the object. Okay, the ball, and so it should be from position of the object. It must be from the position of the object on the left. Okay, so please draw the diagonal, which is the total velocity.
Here.
The actual velocity. I'm waiting for it to appear on my screen. Okay, 7.4 meters per second. Unit meter per second. And the next thing, we need to determine the angle to the vertical, which means this angle. This angle theta. Use the sine or cosine or tan. Determine that angle theta. The velocity, of course, you need to put the arrow here. It is an arrow, not a straight line here. A vector. Okay, tan. So that angle is 33 degrees. Okay, good. So question C. After bouncing on the plate, the ball rises to the vertical height of 0.98 meters. Calculate the vertical component of velocity of the ball as it leaves the plate. Vertical height, new vertical height. Okay. This new vertical height, 0.98 meter, is definitely smaller than the initial height, 1.96 meter, that it was dropped. Okay, it must be smaller because there is some energy lost to the surrounding, to the ground, when the ball collides with the ground. The energy is transferred to the ground, and the thermal energy inside the ball partly. Okay, so for this new height, 0.98 meter, we have a new potential energy, mg, and this new height. Okay, so multiply with mg. M is, do we know the mass of the ball? We don't,
No.
Okay, it doesn't matter. Later you'll see the reason why the mass doesn't matter. The mass, and then 9.8. This is the potential energy EP of this ball. Okay, and when it's bounced off the ground, leaving the ground and go to the new height, the velocity is in this direction. This is the velocity, and it has two components also. The vertical component here, this is the bounce off velocity. Okay, that we don't need to calculate this thing, but we need to calculate the vertical component here. And the other component is this Vx new. Okay, Vy new. We need to calculate this one. And this one is calculated by the conservation of energy. Conservation of energy, which is this potential energy is obtained by the conversion from the kinetic energy 1/2 mv squared. This velocity is not this velocity, but the vertical component of the velocity, what we need to find. Okay, so 1/2 mv nu in the vertical direction here, square the kinetic energy is equal to this thing, m times 9.8 times 0.98, and then you see that the mass cancel out on both sides of the equation, and therefore we don't need to know the mass, huh? And from this equation you can get the value in the vertical direction. Leave the ground and travel in a parabola path like this. The Vy in the top, at the top is 0. That Vy square nu, huh, equal to Uy nu square plus 2ax. A here must be a negative value because the velocity decreases to 0 when going to the top, and A is 0.98, 4.4. Do you have the answer somewhere?
That is correct.
Can you also try using the conservation of energy here? So for Vy in the vertical component to another place. 2 times of 9.8 times 0.98, huh? And then take that square root. The Vy in the vertical direction is 4.34. A little bit different from 4.4, huh?